Hey Java developers, back in Java 25, Flexible Constructor Bodies debuted as a finalized feature with JEP 5.13. Like other Amber features, Flexible Constructor Bodies sought to not only to enable new functionality and improve design options, but to improve the safety of the code Java developers write. In this episode of the Inside Java Newscast, let's review Flexible Constructor Bodies. Before Flexible Constructor Bodies were added, which I realize is the world many Java developers watching this video are still living in, the way class construction would work is to execute constructors from the top of the object hierarchy to the bottom. So, for example, if I have a person class and an employee class that extends off of person, then when I initialize a new employee instance, first the constructor for object is run in full, then the constructor for a person is run in full before finally the employee constructor is run. This was done because logically it should result in a properly constructed object by the time everything is executed. However, spoiler alert, there are some issues with this behavior. When a developer extends a class, it's because the parent class might have some useful characteristics and behavior, and allow for broader and easier use across your system. You know, polymorphism. Let's demonstrate this by having the field age in person and the method print, which will print a person's age and is called at the end of the constructor in person. In the person constructor, we would validate age by making sure it was greater than 0. And if we execute this with a couple of tests, it works well and good. Attempting to create a person instance with an age of -1 throws an illegal argument exception, while constructing a person instance with an age of 10 prints out the person's age as defined by the print method. In employee, the definition of a valid age is different. We will want to make sure someone's age is between 18 and 65. Going by pre-Java 25 rules, in the employee constructor, we would need to make the call to super first and then check age, throwing an illegal exception if it's outside the valid range. When we test this code with an invalid age and valid age, we see an issue. With the invalid age instance, an illegal argument exception is still thrown, but not before printing out the employee's age. This can be fixed by creating the static method validate age and calling it inline in the call to super. Rerunning the tests fixes the issues we were seeing before. This obviously works, but is a bit convoluted and may not scale well with larger data aggregates. If a class has a dozen fields, having to write a dozen static methods to validate each field and including them all in the call to super would look a bit weird and wouldn't be a recommended practice outside the context of a constructor. There is a more pernicious issue though. In the employee class, we would also have an employee ID field. We would also update the print method in employee to print out age and employee ID. Employee ID, of course, makes sense in employee, and hopefully we don't one day live in a dystopian cyberpunk future where children are immediately employed on their birth. But until then, this creates a bit of an issue in the employee constructor, as the person constructor only has a single argument for age. So, following pre-Java 25 rules, we need to do validation for employee ID after the call to super. Our update the static validate method we created in the previous section to be quite strange to validate fields we won't be passing to the parent constructor. However, this is not the major issue with this code example, because if we pass in a valid age and employee ID in the message printed out, the employee field ID field is null. This is because the print method is called in the person constructor before we have set the employee ID field in the employee constructor. There's really no way to resolve this issue outside of performing some refactoring to the person class, which in a real-world system with a lot of interdependencies could create a pretty significant blast radius. And it's also why this behavior is recommended against in books like Effective Java. But now there is a better way. Of course, Flexible Constructor Bodies set out to address the issues we just covered. It would be pretty weird to cover issues without a solution, right? Anyways, with flexible constructor bodies, assignment statements and other computationally safe behavior like validation checks or calls to a static method can be added before the call to the super and a constructor. This can allow us to check the validity of age and employee ID in the employee constructor before calling the person constructor, potentially saving us unnecessary work. We can also set employee ID before, which resolves the issue with employee ID being null in the print message. Altogether, this reduces the need to write potentially convoluted code in constructors and also prevents parent classes from violating the integrity of child classes. One thing you cannot do, however, before the call to super is call an instance method, even if that method is defined within the local class. Attempting to add an instance method before super will result in a compile error. With the update to constructors, now the prologue in the local class will be executed before calling a parent class's constructor, creating a nice and rational telescoping behavior for constructors. Deep object hierarchies were sometimes avoided because of the top-down initialization behavior, which could result in the weird and convoluted behavior we covered in this video. Once you have made the update to Java 25 or later, it might be worth considering either refactoring existing code to be more hierarchical where appropriate, and perhaps taking advantage of other features like sealed classes while you're at it. Or at least keeping flexible constructor bodies in mind when designing new features and applications. Alright, that's it for this episode of the Inside Java Newscast. Be sure to like and subscribe if you haven't already, and until next time, happy coding!